Hey everybody. So I'm going to try and explain a little bit about the push and the pull and the block experiment. So you should have made your columns and you should have put your information down in your science journal, next blank page. You're always going to try and move the block, but I thought you might not have an eye hook to put in your block, so you could use a stick for the first one. So the second column is for where the object that you used to move the block, and then the third column is what object did you see move. Did the block move or did the object just move? That's where you record that. And then in the last column, decide was it a push or a pull, or are you not sure? So stop right now and go do the experiment, and then come back and start up in just a minute. So, two things I need you to know. A push makes two objects move farther apart, and a pull moves two objects closer together. So we would at this time discuss what you saw move by a push or a pull, but I'm not with you, so you're just going to have to discuss it with a parent or another adult. We would record those observations. Things I want you to be sure to know: that this is the concept force. There's a science word that describes all those things that you did that created a push or a pull. Scientists call this a push or a pull, a force. Every time you were able to push or pull one object with another object, that's an example of force. A force is always a push or a pull in third grade. When scientists gather a lot of observations, just as we're going to do today, and I'll show you a picture of what we created in class Thursday on the Zoom, they look to see patterns that they can notice. For example, what's similar about all the observations? What do you notice about what we wrote in the third column? Is there anything the same about all things that we observed? Hopefully the block moved in all the observations. Maybe not. The rubber band and the balloon made pulls and not pushes, and we always touched the block with something, and there were more pushes than pulls. You should have seen that. One thing that all of this is you should have noticed, and I noticed too, is that each time there was a push or pull, some kind of movement was observed, and that's really useful, important pattern to notice. It tells us that when we observe something start to move, it's a clue that there's a force acting. We can't see the force itself sometimes, but we see the movement that the force caused. And those clues are evidence, and evidence is a word that I need you to kind of know this year. Evidence is information that helps explain something or answers a question. Observing a block move is evidence that helps us know that a force is pushing or pulling on the block, even though we might not can see the force itself. And scientists use evidence in all of their work. So, how does an object start to move? That's our essential question. So we'll talk more about it later. Bye.